Hello students, here we have a question based on grade 10 quadratic equations. A train travels 360 km at a uniform speed. Uniform speed, that means the speed of the train is same throughout. It is not going slow and fast, it's the same throughout. If the speed had been 5 km per hour more, that means whatever the original speed was, if we increase the speed by 5 km per hour, it would have taken 1 hour less for the same journey. So here there are two cases. In the first case, we are taking the original speed of the train. So I'm going to talk about first case 1. In case 1, the distance which the train is traveling is 360 km. Now the speed of the train is not given in the question. Though it's given that it's a uniform speed, but the speed is not given to us. We have to find the speed in this case. So the speed I'm going to take as x kilometer per hour. Now the time taken in the original case, where the speed is x kilometer per hour, would be 360 upon x. Now how did I get 360 upon x? That's distance upon speed. So this is 360 upon x hours. Now coming to the next case, case 2, when we increase the speed. Now in this one also, the distance is the same. The train is traveling the same distance, that's 360 km again. The speed in this case, we are increasing by 5 km per hour. So I'm going to write this as x plus 5 km per hour. Now the time taken in this case would be less than the time taken in the previous one because we are increasing the speed of the train. As the train goes faster, the time taken by the train would be less. In this case, the time is distance upon speed, that is 360 upon x plus 5 hours. So this is the time. Now in the question, it is given if the speed had been 5 km per hour more, it would have taken 1 hour less for the same journey. So the difference between this time and this time is 1 hour. Now, obviously, this is the bigger quantity. Here, the train is going slower, so the time taken would be more. Here, the train is going faster, the time taken would be less. So this minus this will give us 1 hour. This 1 hour is given to us in the question, that the difference in the time taken in both the cases is 1 hour. So according to the question given here, we have 360 upon x, that's the bigger quantity, minus the smaller quantity, that's 360 upon x plus 5, that's given to 1, that's given as 1, it's given in the question. Now from here, we are going to solve for x. So before we do anything else, we are going to take this 360 common so that we make our calculations easy. So I'm going to write here 360 common, and then I'll be left with 1 upon x and minus 1 upon x plus 5 inside bracket. That's equal to 1. Now I'm going to work with this and I'm going to take the LCM. So we will get 360 into x plus 5 minus x upon x into x plus 5 equal to 1. Now here minus x and plus x will get cancelled. We will take this 360 and we'll multiply it with 5. So we'll get 1800. And this entire thing in the denominator, we are going to take this towards the right hand side and multiply it with 1. So we will get it as the same number, x into x plus 5. Now this x into x plus 5, we are going to solve for the 1800 is equal to x square plus 5x. Now this 1800 I will take on the right hand side, its sign will reverse. So it's positive here. If I'm going to take it towards the right, it will become negative. So we have x square plus 5x minus 1800. Now we want two numbers whose product is minus 1800 and sum is 5, positive 5. So we are going to solve it using split the middle term method. Now here we have x square plus 45x minus 40x. So I've written this 5x as 45x minus 40x minus 1800 equal to 0. So using split the middle term method, I have taken this 5x, I've written it as 45x minus 40x. 45 and minus 40 will give me the sum plus 5 and will give me the product minus 1800. Now, in these first two terms, we're going to take x common. So we'll have x into x plus 45 here. And in the next two terms, we will take minus common. Also, we can take 40 common. So we are going to get x plus 45 again. Now further, we will take x plus 45 common. And we'll be left with x minus 40 here in the next bracket. From this, we can conclude that x is either minus 45 or x is 40. Now, if I take x as minus 45, I took my speed of the train as x. So if I take speed of the train as minus 45, it would not be correct. It's not possible for train to have speed in negative. So we are going to reject this. We will reject this and we are going to reject x equal to minus 45. Now, finally, we are left with x is equal to 40. Thus, the speed of the train is 40 km per hour. So we can just write the concluding statement here. Speed of train, which we took as x kilometer per hour, is 40 km per hour. So the original speed of the train is 40 km.